Using artificial neural networks to predict student stumbling at Najran University. Abstract: the research is concerned with the application of the artificial neural network system, which simulate the neural networks in the human organism, that centered around the designing of neurons that dedicated functions enable us to create a smart neural network through repeated training to reach results, providing time and effort to the community. The sampling used in this research are students who expected to stumble. The study is conducted to use a new method to enable predicting the stumbling before it occur by sorting and processing the inputs to produce a list of expected stumbling students order to solve their problems by calculating their progress and cumulative GPA rates. Keywords: Artificial Neural Network System, and predict. Acknowledgement: the authors are thankful to the Deanship of Scientific Research at Najran University for funding this work through grant research code new/ESCI/16/065. Introduction. The research focuses on the low achievers of the students, which are the most important university's inputs. The research aims to find a sophisticated method that goes with the latest technological developments. This method is the neural networks. The basic component of the study follows the students' grades through their progress rates during the monthly tests, in addition to their cumulative rates and the number of warnings. The previous variables are treated as the neural network input with specific conditions to predict the stumbling students before they stumbled. 2. Literature survey. 1. Early and dynamic student achievement prediction in e-learning courses using neural networks. 1. The increasing number of students in e-learning has led to the need for accurate mechanisms to predict student achievement. According to this issue, teachers improve the efficiency of their courses to meet the specific needs of their students at an early stage. In this paper, the student's prediction method is presented in the e-learning course for 10 weeks. This research uses advanced neural networks to predict the final student's achievement dynamically and group them into 2 hypothetical groups, depending on their performance. Multi-choice test scores are used as input data set for networks. This type of test was preferred to its objectivity. The results showed that accurate prediction is possible at an early stage, specifically in the 3rd week. In addition, when the students were assembled, low displacement rates showed the adequacy of the approach. The results of the proposed method were compared with those of linear regression, and the neural network approach was found to be more effective at all stages of prediction. The proposed methodology is expected to support trainers in providing better educational services as well as customized assistance according to the expected level of the student's performance. 2. Hybrid data envelopment analysis approach to analyze college graduation rate at higher education institutions. 2. College graduation rates have become a primary focus in measuring institutional performance and accountability in higher education. In 2009, President Obama set a goal for the United States to have the highest proportion of college graduates in the world by 2020. With the heightened focus on transparency and accountability in higher education. Today, university administrators are developing internal strategies to improve graduation rates. In fact, it is not only significantly important to institutions, but also to individuals and to the nation as a whole to increase college graduation rates. In this paper, a hybrid data envelopment analysis (DEA) approach is implemented for the very same purpose. By combining with the cross-industry standard process for data mining, CRISP-DM, methodology. The approach is illustrated by a case study at AU.S. based 4-year public university. We identify the most important predictors of graduation which help improve graduation rates by the CRISP-DM method. It shows that fall term grade point average, GPA, housing status, high school, and spring term GPA were the 4 highest determinative factors, while monetary variables and the ethnic background of the student were revealed to be the least important ones. The results also indicated that students living on campus were more likely to complete within 6 years. For the detailed improvement strategies for increasing college graduation rate, we use the Hybrid DEA methodology, an input-oriented bounded and discrete data DEA model and context-dependent DEA, to evaluate the performance of college undergraduate students. These analyses provide potentially useful information and policy support for university administrators. 3A Microexpression Recognition Algorithm for Students in Classroom Learning based on Convolutional Neural Network 3 Strategy and improve the teaching effect based on the expression and learning state of each student. This paper mainly develops a microexpression recognition algorithm for students in classroom learning, based on Convolutional Neural Network, CNN, and automatic face detection. Specifically, the Multitask Deep Convolution Network, DNN, was adopted to detect the landmark points of human face, and a hybrid DNN was designed to extract the optical flow features of microexpression. The extracted features were improved through redundancy removal and dimensionality reduction. The rationality of our algorithm was proved through a comparative experiment on real-world databases and an application in classroom teaching. The research results provide a new direction for applying deep learning in face recognition. For training neural networks using reduced training sets for artificial neural network, and may require long training time. Deciding when to stop the learning algorithm is a crucial issue. Too much training causes overfitting, however too little training would not be enough to obtain good classification accuracy. In this work, we investigate the effect of applying instance reduction techniques on training sets before we use them to train neural networks. The hope is by doing so, we would be able to reduce the training time without substantially decreasing the classification accuracy and at the same time reduce the effect of noise in the training sets. We also investigate the effect of using the reduced set as a validation set, to decide when to stop training. Our experiments show that using instance reduction techniques have positive effect on the classification accuracy in the presence of noise in the training set. Our results also show that reduced training sets serve as good validation sets. 3. Research methodology. The first stage, building the neural network in terms of choice of the type of networks, the number of layers, the selection of weights and other things, through the designing of diagrams linking input to the output through processes that correspond to the structure of the network. The first stage was completed through 3 steps: 1. Classification type. 2. Revenue determination, xi, yi, and weights, wi. 3. Choose an activation function. 4. Building a neural network. Stage 2, training the neural network through the MATLAB 2010 program. The second stage is done in 2 steps: learning rate neural networks training steps. 4. Experimental analysis. 4.1. Neural network training. 4.1.1 Weights initialization. Conventional W1 equals W2 equals second month, W3 equals work of the year. WI, first month grades 10/2 equals 5 degrees, 10/2 equals 5 degrees. Grades 10/2 equals 5 degrees. Neural network, WI asterisk 0.1. 0.5 0.5 0.5. 4.2 Inputs application. Conventional, xi, x1 equals first, x2 equals second, x3 equals work of the month, grades for student, year for student. Neural e.gx equals 2, e.gx equals 5, e.gx equals 1. Network, xi asterisk 0.1. 0.2 0.5 0.1. 4.3 Sum of inputs, weights, products. Calculate the total net input for H1. Net H1 equals x1 W1 plus x2 W2 plus x3 W3 plus B11 equals 0.2 0.5 plus 0.5 0.5 plus 0.1 0.5 plus 0.32 1 equals 0.52. Using the logistic function to get the output of H1. Out H1 equals 0.62714778. Asterisk repeat operations for H2 H3. 4.4 Calculating the total error. Sum of squared errors, SSE, is the function which needs to be minimized. SSE is a squared difference of calculated outcomes and true class labels. V. The results. Subject trainee NG error test error activation function neural network result conventional result. Computer programming 10.0132780.0004756 signum activation functions 21.3% 20.0%.